Today we will be talking about data types and sources. First question is, what is data? Here's an example of what some would consider data. This is the distribution of Idaho salaries in 2018. As you can see, the orange bars are Idaho salaries, whereas the gray bars are the average salary in the whole United States. We can see that we have a higher percentage of adults making less than $10,000, between $10,000 and $20,000, between $20,000 and $30,000, and between $30,000 and $40,000. So those lower income salaries, Idaho has more people out of their population making those salaries than the rest of the United States. As you can see, as those salaries increase, the United States then has a higher percentage of people making those higher salaries. That's probably because Boise is a low income or a lower cost of living, you would think. Though recently, our cost of living has increased dramatically and our salaries have not caught up with that yet. So that's a topic for another day. The definition of data is systematically collected and interpretable information. So a couple student questions. Is data the same thing as numbers? Is a chart considered data? Is a table considered data? Are statistics data? And is data plural or singular? The answer to these questions is data is actually a collection of facts, such as numbers, words, measurements, observations, and just descriptions of things. So it doesn't have to be numbers. We can collect data that's just words. We can collect data that is observations, that are descriptions. Data can also be numbers, so it's all of those things. A chart is a visual representation of data. So the data is the information that we collect. A chart is one way we could represent that data that was collected. A table is an arrangement of data, and statistics is the result of data analysis. So statistics is the thing we do with that data, the way that we analyze that data. Fun fact, data is actually plural. The word datum is singular. It's also pronounced a couple different ways. You'll hear it data or data, depending on which way you lean. I'd prefer to say data. But you could do either, both are correct. Data is plural though, so we need to use the plural articles with the word data, which is not commonly used or commonly misused. There are general types of data. The two basic types are the only two covered in the Common Core, and that's categorical data and quantitative data. Now, the tricky thing is categorical data is also known as qualitative data, and that's because it describes the quality of something. So if you were thinking of how to categorize something in terms of labels or words that describe that thing, qualities about that thing, categorical data and qualitative data are synonymous. They describe attributes of a data set. For example, if the variable was favorite musician, that would be a categorical variable because favorite musicians are words, they're labels, they're not numbers. And most importantly, it doesn't make sense to take an average. It doesn't make sense to take the average favorite musician. They're not even numerical ways to calculate that. So, for example, your variable could have favorite musician as Jimi Hendrix or Bob Dylan or David Bowie, etc. It's a little bit confusing because sometimes we label categorical data with numbers. So we'll take a characteristic and we'll assign it a value, whereas that value is not actually measuring anything. And it wouldn't make sense to take the average, in this example, letting 1 represent male and 2 represent female. If we took the average and said, the average of this data set is 1.7, that 1.7 wouldn't really tell us anything. And so categorical data, again, it's things that are labels, things that are words, numbers that just label something, like an address would be categorical data because that address number, it is not actually measuring anything. If I live at 11,543 in my address versus someone who lives on like 23rd, that doesn't mean my house is bigger or better or cooler or anything than the other person's. It's just a label. Another label that would be a number would be like a jersey number. A jersey number on a team is a number that's chosen that doesn't measure the skill of that player. It doesn't measure how many fans they have or any type of thing about that athlete. The jersey number is just a label. So that would be categorical data as well. Remember, categorical data and qualitative data are the same thing. Quantitative data comes from the root word quantity, and that's measuring how much. It's numerical data, it's measuring something, it's appropriate to take an average. So this is going to be numerical number data. And that data we're going to take summary statistics of. We're going to take the average, and that would make sense. We're going to find the median, we're going to find the mode. Quantitative data is measuring something. So it's numbers that measure something. There are two types of quantitative data. Discrete data, which has distinct gaps, like shoe size. You could be an 8.5 or a 9 or a 9.5, but you can't be an 8.7 shoe size. Also measurement data. Any value is possible. So that would be like height. You could totally be 6'1" 3/4", or anything in between. It's just how precisely we measure those things. So discrete data has distinct gaps where there's only certain possible values with nothing in between. And then measurement data is measured to the degree of accuracy with which our tools will allow. Let's practice by looking at shark attacks. This data came from a Google Doc, and it records the date, the year, the type of shark attack, the county, or pardon me, the country, the area, the location, the activity the person was doing when they were attacked by the shark, the name of the person, their gender, their age, the injury that that happened to them because of the shark attack, whether it was fatal, yes or no, the time, the species, and the investigator or source for that reported shark attack. So we're going to label each of these variables. Each column represents its own variable, and C is going to stand for categorical, and Q is going to stand for quantitative. So remember, categorical is a label. The data is going to look like words or sometimes numbers, but numbers that don't actually measure anything. And Q is going to stand for quantitative. Quantitative has the root word quantity, and that means it's going to be numerical data where it makes sense to take an average. So let's practice. The first one on the left, date. Is the date is kind of comprised of numbers, but is it measuring anything? I would say no. The date is going to be categorical. C for categorical. The year, 2020. Year is tricky. Year can sometimes be quantitative. Like when I try to think about taking the average year, I see that they're numbers, so I'm leaning towards quantitative. When I think about taking an average and saying the average year for a shark attack is 1973, and I don't think that would actually tell me anything about the data set. So I'm going to go categorical. Even though years are numbers, it doesn't make sense to take an average year. So year is also categorical. The type, those are words. So I know automatically that's a label. That's going to be categorical. The country, words, label, categorical. The area, words, label, categorical. Location, same thing. Activity, same thing. I'm just going until I see a number. I know for sure anything that has words is definitely categorical. Male or female, categorical. Ooh, age. Okay, here are some numbers. Would it make sense to take an average age? Average age of a person to get shark attacked or attacked by a shark. Yeah, that would totally make sense. So that would be quantitative. That's our first quantitative variable in this data set. Injury, I see words, definitely categorical. Fatality, I see words, well, letters, so labels, categorical. Time, ooh, time is interesting. Sometimes time is categorical, like if you were listing the time at which they got attacked. But this looks like it's measuring something else, like how long. When I look at the data, I see 9 hours and 40 minutes, 8 hours, 20 hours, maybe how long they were in the water before the shark attacked them, or how long it took them to get help after they were bit by the shark. I'm going to go, because they're measuring amount of time, that would be quantitative. If they were just measuring the time of day, I would say categorical. But I think they're measuring a duration, so I'm going to go with quantitative. Species looks like narrative text, so that's going to be categorical. Those are labels. And the investigator, again, categorical. So most of these variables were categorical. Now let's get a little fancy. So outside of the Common Core, statisticians have other names for types of data that come up rather frequently. So there's temporal data. That's data corresponding to times, very common in the sciences and often autocorrelated. So we take a look at how different values change over time. The stock prices, stock market is a great example of that, temporal data. So you're looking at time versus something else, how things change over time, temporal for time. There's periodic data. This is often used in the sciences as well, data tied to a repeating cycle. So it allows us to compare things within the cycle period and also across the cycle period. For example, cell growth follows the lunar cycle. So if we follow the cycle of the moon, we can track the difference in cell growth, and they actually are quite commonly aligned. And you'll notice when you become a teacher that there'll be these random days when your students will go crazy, and you'll be like, everybody seems to be off their rocker today. I don't know why. And it'll be a full moon, and I have no idea why. I never believed in this kind of stuff before becoming a teacher, but all of a sudden, every day that my kids were like wild and crazy and unruly, it was always a full moon. So there's something about those lunar cycles. There's also dichotomous data, which is also known as binary data, and that's just where there's two possible outcomes. So you can see in our shark data before, there was a column for fatality or fatal. Was the shark attack fatal? It was a yes or no. That would be an example of dichotomous data. We called it categorical, which is the Common Core vocabulary, but dichotomous would be a more precise term for that, or binary would be a more precise term. There's two possible outcomes. It's a success or a failure. They died or they didn't die in that particular example. The last one is Likert type data. Standardized ordinal scale, usually 4 to 7 options, often converted to numbers. So those course evaluations that you guys have to do at the end of every semester are Likert type data. So they would say strongly agree or always or never or sometimes, and they correlate those to numbers, or often convert those to numbers. Multiple variables are often grouped to create a scale. So participants in the survey would choose one of those values, often converted then to a number. And that's called Likert type data. Excellent. So those are the types of data. I hope this helps you with your check for understanding, and we'll see you in class real soon.